come down together. The other type of chuck we have in our shop is a 4-jaw independent chuck, and you would have to tighten these jaws up in 4 places. They all move just one at a time. That's really good if you want to take a square part and chuck it, and even be able to move it off center. Or you could chuck something kind of the shape of a brick, you know, something real long, and you could move it from side to side, and you could drill holes in different positions. That's what a 4-jaw chuck is for. A 4-jaw chuck will chuck on things round or square or even hexagon in shape, but it won't hold all parts. So there's 2 kind of chucks. 3-jaw universal, and they come in 2 jaws, 3 jaws, sometimes 6 jaws. They all come down at the same time, moving only 1 screw. Independent chuck means the jaws go in 1 at a time. So you have to tighten here, tighten here, tighten here, and normally you have a little test indicator to see your part is in the correct position or running right on center line, dead center. Find the true position. Okay, tailstock. The tailstock can be moved in different positions, locked down, and then this thing that comes out is called the quill. A lot like a milling machine. The quill does not rotate, and there's 2 basic tools that go in the quill, and one of them is a live center. This is on ball bearings, and so we can put it in a long part and turn parts. It's called turning between centers. They have a Jacobs, a Jacobs taper, Morris taper, not a Jacob, Morris. We talked about Morris. Remember when I put a drill in a adapter over there, we tried to pull it apart and it wouldn't work until I knocked it out of there with a pin. And then this chuck will chuck up to 1/2 inch in diameter, and we put in drills and reamers in this, and then we can feed it into a hole in our part and either drill a hole or ream the hole out. And so this chuck is used for drilling and reaming and a carriage. It's made up of a saddle, and that would be this big casting that goes from side to side, called the casting. This part that moves in and out is called the cross slide. And then this little thing rotates at different angles, so we can we can form angles on our part, which you'll do on this part. And it has protractor numbers over here, and so we can set it right on the angle we want it to within, you know, like 1 degree. So it has a lot of uses. So this is called the cross slide. It just moves in and out. It runs at a right angle to the center line of this machine. The center line would be coming right down the spindle, ending up right here on this center. Here's a good example of the center point. See the point of that thing? Would be like the center line of the machine. Okay, so cross slide, compound. On top of the compound, we have a quick change release tool post. Tool post. This is a famous old brand. They just call it KDK. Here's the guy's name. It's Jack Kuhn, K-U-H-N. I met this man one time. These have been around for like, 80. And release tools, so you can change parts and you can make setups using multiple tools. And that's all you have to do is unlock it, put it back, take this one, put it back in, and now we can face or we can turn. And with this one, we might, on this block, we might have a part-off blade. So they have 2 ends. You can use this end, or you can flip it over. You can use this end. So it's very universal. There's a lot of things you can do with this. You can make multiple tool setups. If you were working in a small production shop, that would be very important. A couple of things to understand is when we put this down inside here, here's a T slot, and then this is down, this thing is a custom-made T nut. If you use your imagination, this kind of looks like the letter T over here. between the rotating jaws and this edge. If you look at all of our machines, right there, not so much the newer machines, look at some of the older ones. This corner has been broken off most of those old machines because people make a setup, they have to get too close to the chuck, and then the jaws come spinning around and they hit the machine right there and break a big hunk of that cast iron off of there. So that's why we favor the left side. We also run this compound. Don't expose the shiny ways down here. This is the tracks that this thing runs on. It allows movement, but there's very little movement this way, almost none. Okay, so carriage, cross slide, saddle, compound rest, tool post, universal tool post, or quick release tool post. Then this whole thing runs on tracks, kind of like train tracks. Here, one's got a V shape in it to keep this thing going straight. This one over here is just flat. It also uses the side here, or sometimes they have another set of rollers that rolls down here. It depends on who made the machine. These are called ways, W-A-Y-S. They are kind of like the accuracy of the machine. If machines get beat up and these get chipped and banged and dented, they are hardened steel, but you can dent them. You know, if I sat here and beat on it all day with a hammer, I'd put marks in that. They take away from the accuracy of the machine. You can start the machine. It's a built-in safety feature. Some of the older machines don't have these guards. Don't worry. They're nice to have, but if they're not on the machine when the machine was built, then that's okay. So now I'm going to take this part and I'm going to put it in our chuck. Now we have, he lost part out of the machine. We have safety chuck keys. They have a little spring-loaded thing on here, so you can't leave the key in the chuck. If I let go of that, it just pops out. The reason for that is it's very dangerous to leave a key in a chuck. If you forget, go away, go have a cup of coffee or something, come back. Here, stand right here. I'll turn it on. No, yeah.
911.
You'll kill him. Or kill them over there. Whatever's in line with this chuck. This thing will go. So that's why we have safety keys. It's kind of a pain in the neck, but if you hold that down there with one hand, you can turn this with the other hand, and it goes pretty fast. But it's just like any other safety device here. We want to use it, help protect ourselves and protect you guys that are working around you too. Make sure your part is in the middle of all those jaws. I could tighten this up over here, right? But that's wrong. See, now we got a part that's not right. Make sure you sit in between all three of these jaws. And I got a light up here on the tachometer, so I know it's ready to run. Now these machines, these are, I'll just say these are entry-level machines. These are kind of like machines to learn on. So they only have two gears. That's forward. Always cut forward. If you take this lever and push it down, that's reverse. Your cutting tool would not cut when it's going in reverse. Just like the end mills over there on the milling machines. They wouldn't cut if they were going backwards, right? They won't cut. Alright, so we're not quite done yet. Next thing, notice the last thing I'm doing is put it inside my cutting tool. Most of these, this should have a full set of Allen wrenches here. Try to use them and put them back. I've just demonstrated a very bad habit. Don't stack things up here too much. They're good for a couple of things, but that's what this little table's for. Use this table. Now these little set screws get sometimes filled with chips. If you get the chips to fall out, then these go in much better. stick it out. Well, you kind of have to use your brain. Here, that's about 3/4 of an inch. This is too much. This is not enough. So you want it out about like that. Maybe from here to the end, 3/4 of an inch, almost to an inch. Most things can go out maybe a maximum of 3 times their diameter. So if this was 3/8, we could go out 3/4 of an inch. Right? Oh, actually, what? More than that. Yeah. 3, 6, 9. No, it'll go out an inch.